Advanced Object-Oriented Programming, Inheritance and Extending Classes. Hey everyone, welcome back to the channel. In today's video, we're diving deep into inheritance and extending classes, concepts that are foundational to object-oriented programming. If you're already comfortable with the basics, then you're in the right place for a more advanced discussion. Quick recap. What is inheritance? Let's quickly remind ourselves of the basics before we move on to the more advanced concepts. Inheritance is the mechanism in OOP where one class can inherit the properties and methods of another class. Think of it like a child class inheriting features from a parent class. For example, imagine we have a vehicle class. A car class can inherit from vehicle, gaining all of its attributes like speed and fuel, as well as its methods like accelerate and brake. But here's where it gets interesting. The car class can also extend those capabilities, or override them to suit its own behavior. Extending classes, why it's powerful. Now let's focus on extending classes. This is where inheritance gets its real power in OOP. When a class extends another, it's creating a subclass based on an existing class, reusing its code while adding more specific functionality. Essentially, extension involves creating a subclass that inherits everything from the parent class, but has the ability to override or extend methods to behave differently. This gives us a huge advantage in terms of code reuse and scalability. You can maintain the same high-level structure in your parent class, while the subclasses can customize or add new features. Advanced method, overriding and polymorphism. All right, let's dive into some advanced concepts tied to inheritance, method overriding, and polymorphism. Method. Overriding allows a subclass to provide a specific implementation of a method that is already defined in its superclass. It's a way to alter or specialize the behavior of a method depending on the subclass. This is one of the core strengths of inheritance because it allows the subclass to fine-tune or completely change the behavior of a method it inherited from the parent class. And then there's polymorphism. Polymorphism is a powerful feature that allows us to treat objects of different subclasses as objects of their superclass type. This means that you can call the same method on objects of different types and get different behaviors depending on which subclass the object belongs to. This is particularly useful in scenarios where you want to design flexible and reusable code. Constructors and inheritance. Now let's talk about constructors in the context of inheritance. Constructors are not inherited in many languages, but they can still be invoked from a subclass. When you extend a class, you can define your own constructor in the subclass, but you can also call the constructor of the superclass to ensure that the inherited fields are properly initialized. This is important because it ensures that both the parent and child objects are set up correctly when they're created. Understanding how constructors work in an inheritance hierarchy is key to writing robust and maintainable code. Multiple inheritance challenges. Now, let's touch on multiple inheritance, a concept that can be tricky in object-oriented programming. Multiple inheritance allows a class to inherit from more than one class. However, this can create complications, especially if two parent classes have methods with the same name or implementation. In many programming languages like Java, multiple inheritance is not directly supported because it can lead to problems like the diamond problem, where a class inherits from two classes that both inherit from the same superclass, causing ambiguity in method resolution. However, languages like Python allow multiple inheritance, and while it introduces flexibility, it also requires careful management to ensure that methods are properly resolved. Understanding how to manage multiple inheritance is crucial for building maintainable systems. Key takeaways. So, Let's wrap up. We covered how inheritance allows you to extend classes and reuse functionality, how overriding methods introduces flexibility, and how polymorphism enables dynamic behavior. We also touched on constructors and the challenges of multiple inheritance. When used correctly, inheritance can make your code more modular, scalable, and easier to maintain. But with great power comes great responsibility. Always be mindful of potential pitfalls like tight coupling and deep inheritance hierarchies. Like, subscribe and comment. If you found this video helpful, don't forget to hit the like button, subscribe to the channel for more advanced programming content, and leave a comment if you have any questions or want to discuss inheritance further. Until next time, happy coding!